Okay, today we're going to finish 1-5. Yesterday we talked about how to name angles, how to measure angles, those types of things. Today we're going to use angle addition postulate, which is talking about when we add two angles together, how we can solve, and then also congruent angles. Okay, so on page 2 of our notes from yesterday, we're going to start where it says angle addition postulate. The postulate tells us that if we have two adjacent angles, we can add those two angles together and it is equal to the total, right? Which that should make sense to us that this top angle, ADB, if we add that to BDC, should equal the total. Agree?
Oh, yeah.
Similar to when we had the segments, right? And we said this first segment plus the second segment has to equal the total. Okay, so that should make sense to us. All right, so I'm going to give you a measure for each of these. So let's say the measure of ADB is 32, and then BDC is 40. Okay, so
32.
I could use that, right? ADB we said was 32 plus BDC was 40. So then we know that the total angle is going to be equal to 72 degrees. Now, that's like the simple way of doing it. There's going to be some that get a little more complicated, a little more work involved, but really not too bad. Okay? All right, let's look at these few examples. Example 1 says, given the measure of ADB is 32 degrees, and ADC, what is ADC? The whole entire thing. So you might draw like a line across this whole thing and label that part as 73. Okay, and then we want to find the measure, of BDC. Okay, I'll try to use different colors. I should have done that here. That way it's a little less confusing for you, at least on my part.
Are we going to use X or can we just subtract the 2?
You will have to use X.
Okay.
Okay, so because again, not all of these are you just going to have an angle measure, right? Like the one next to it. So this red angle we don't know, we're going to call X. So just like we did with segment addition postulate, we're going to do the same thing here. We add the two small parts or the two adjacent angles and we set it equal to the total. So what would be the equation that I would write for this?
X plus 32 equals 73.
Good.
Don't forget your picking time.
Okay, you're correct. I'm not going to be overly picky about that, except probably on your answer. Okay, so two angles added together, set it equal to the total. Okay, go ahead and solve that, Austin.
Minus 32, X equals 4.
Okay, we subtract 32 from both sides to get X by itself. So X is equal to 41. Now, how should I write that out? We talked about this yesterday, the measure of that angle.
BDC, wait, measure, and then the angle thing, BDC equals 41.
41 degrees. Okay, I know a lot of us are in the habit of just solving, and if X is what we want, we just stop and put that there. But you have to write that out each time, okay? Because it asks you specifically find the measure of BDC. Now, on number 2, what does it ask us to find?
Find
X
X.
and,
Measure each angle.
okay, so we're going to have how many answers here?
2.
3, okay? We'll have an answer for X, and then we'll have a measure for each angle, okay? All right? Any thoughts?
Would it be 4x plus 1 equals 9 plus x?
Okay, are those two angles congruent angles? No, right? What would it have to tell us in order to know these two angles are congruent? What would be through those angle arcs? The lines, right? And we don't see that. So they're not congruent, but what do we know about these two angles together?
They're going to equal 90.
They're going to equal 90, right? So then what should I do to make them equal 90? Say it again, Jordy. Yeah, okay. So if I add them together, I would get 4x plus 1 plus 9 plus x is equal to 90. Okay, anybody want to take this one? You already went. Go for it, Felipe.
The answer?
Well, like, tell me how you would solve.
So numbers one side and the letter is other side, so
Okay,
like
so if I add my x's, what do I get?
4x plus x equal 90 minus 1 minus 9. So
Oh, you're subtracting one?
yeah.
I got you. Okay, before we do that, let's go ahead and add our like terms together. Okay, so 4x plus 1x, we're going to get 5x. And then 1 plus 9, we're going to get 10. Okay, now I'm okay if you move it over, right? Is everybody with me on that? Okay, so we subtract 10, we get 5x is equal to 80. And then our last step to get x by itself, divide by 5. Good. 16. Thank you. Oh my gosh. Okay, so x is equal to 16. There's our first answer, right? What else do I have to do?
Plug in.
Change the x off the equation.
Good. Now, I'm okay even if we write this up here, 4 times 16 plus 1, and then 9 plus 16. Now, it doesn't give us a name for these angles, right? So I can't put measure of angle something, because I don't have that. So on this, we can just write our two answers. So, what is 4 times 16? 64. 64 plus 1. So our first angle is 65 degrees. What's 9 plus 16? 25. So on this, it's okay if we just write our two answers out. Okay? Good. All right? Bless you. Okay. So, if we have two angles that are complementary, right? Complementary means they add to equal 90. That's what we just did. What word tells us they add to equal 180? No. Complementary adds to equal 90. What word tells us they add to equal 180? Starts with an S.
Straight.
The segment?
Nope. Did we not talk about this yesterday?
Unshared.
We should have written that yesterday.
Shared.
I just said
No, they do have a shared side, but supplementary. Okay, let's write that
I
then.
knew that. I don't know why I didn't.
Okay, let's write this up here. Okay, I apologize. It might be something we do later, honestly, but it's okay for us to know now because we're doing it. So, complementary angles are two angles that add to equal 90. Supplementary angles are two angles that add to equal 180. So on example 3, we have two supplementary angles, right? Because they form a straight line. So, similar to how we solved on example 2, how can I set this up to solve for x?
2x plus 12 plus 6 equals 180.
All right, Turner. Go ahead and solve for me here.
You're gonna make it to 6x or 8x plus 12.
Good. Add our like terms. So we get 8x plus 12 equal to 180.
And then you're gonna subtract 12.
Okay.
And that's 168.
Good. Last step.
Then you divide by
21.
Thanks, Turner.
You're welcome.
All right. Now, Turner, am I finished with this problem?
8.
No. What else did they ask you to find?
Find the angles.
Okay. So 2 times 21 plus 12. What's 2 times 21?
42.
42 plus 12.
54.
Okay. So our first angle, 54 degrees. And then down here, 6 times 21 is equal to 126. Good. Okay. Well,
You
listen,
better write that too.
me yesterday, so it's fine.
I'm just gonna.
Okay, are we okay with these three? Questions on any of that? Okay. Oh, sure. Now, we did talk about congruent angles just a little bit ago, okay? Congruent angles here are marked with an arc, right? We do. We do. Okay, so if we mark congruent angles with an arc, now we did talk about earlier, sometimes those arcs can have lines through them, but that's really if you have like extra sets of angles, right? Or they'll use a double arc. If I have two angles here and when they want to show both those are congruent, sometimes they'll put double arcs on there instead. Okay, so if they just have this arc here, that means CBA is congruent to RQP. Okay, all right, who can tell me first what are the names of these angles?
CBA.
True. What would be the easiest way to name these two angles?
B.
Angle B and angle Q. Now, CBA and RQP are also correct, all right? But if we can name them quicker, let's do that. How could I show that the two angles are congruent? What symbol would I use?
Double arc.
No, what symbol shows that?
Oh, is it?
The what, Joss?
Do wavy equal.
Kind of. Equal sign with the wavy on top. Okay? Okay, who can tell me the measure of angle B? 30 degrees. What about the measure of angle Q? Also 30 degrees. This is just kind of giving us that reminder of how we write these out. Okay, can I say that the measures of the angles are equal? Yes, so the measure of angle B is equal to the measure of angle Q.
I'll write that again.
Okay. All right, so just a quick reminder on that. Now we're going to talk about angle bisector. Now, we talked about segment bisectors last week. When we talked about a segment bisector, what did that do to a line?
Cut it in half.
Cut it in half. So what's an angle bisector going to do?
Cut it in half.
Cut it in half, okay? So the difference here is it's a ray that divides an angle into two congruent angles. Austin, sit up. Okay, so on example 1, it tells us that QS bisects angle PQR and that the measure of PQS is equal to 5x, okay? Now, if PQS is equal to 5x, what do I also know about SQR?
5x.
Also equal to 5x, okay? Because here, do they give us the measure of this whole entire angle? Yes. What's the measure of the whole angle? 75, okay? So, can anyone tell me how I could solve for x here?
5x plus 5x equals 75.
Good. Add the two parts, set it equal to the total. Okay, what's 5x plus 5x? So I get 10x is equal to 75. We all know our last step is going to be divide by 10. So our value for x, like 7.5 or 7.5?
Well, I just did it in my head better.
Oh. Well, I just want to make sure we're sure. Because it is
Yes, I'm-
for sure 7.5.
It's for sure it's 7.5.
Okay. All right, good. So who can tell me then what my measure of angle PQS would be?
37.5 degrees.
No, that would be like
Not the whole measure.
30.
Oh, yeah, 37.5.
We would plug it in for, oh, sorry.
37.5
Okay, how would I get that, Austin?
times 7.5 plus 5.
Yes. Okay, because you have to plug that back in. 5 times 7.5. Okay. Now, if PQS is 37.5, what do I know about SQR? Same thing, right? Also 37.5. And then I don't have to do any work for PQR because it gave it to us. But even if it didn't, what could I do with these two numbers?
Add them.
Yeah, because the two parts have to equal the total. Okay? All right?
Alright.
So, one way is it gives you one angle, we match the other angle and set it equal to the total. Because here they gave us the total. Now, example 2, did they tell us what the measure was of this whole entire angle?
No.
No. But what do we know about these two angles?
They're greater than 90.
Maybe. They are congruent. We do know that. Why do we know they're congruent?
Bisect.
This word right here tells us, right? Ray BD bisects the whole angle, so I know that this angle is congruent to the one next to it. So if I know these two are congruent, how can I solve? What does congruent mean?
I'll set them equal to each other.
Equal. Yeah, I set them equal to each other. So this is where we have to be careful. We have to understand, when do I set them equal, or when do I add and set them equal to a total, okay? So 10x minus 51 is equal to 6x minus 11, okay? Symphony, will you solve that for me? Okay, I'm okay if you go ahead and move 51 in that same step. Okay, and what are you left with? 40. Okay. Last step. Good. So we have our first value. X is equal to 10. Then, Symphony, what would I do to find the measure of those angles?
10 times, 10 times 10 minus 51.
Okay, 10 times 10 is 100. Minus 51 gives us 49 degrees, which means without any work, this has to be what? 49 degrees. But let's just check it. 6 times 10 is 60. Minus 11, also 49. Okay? Then how can I find the total measure of angle ABC? Add. What's 49 plus 49? 98. Good. Okay? All right. We feel like those two are doable.
Yeah. Pretty easy.
Okay, we ready for the last one? Okay. All right. In example 3, KJ, which is this ray here, and KM are opposite rays. They form what type of line?
Straight.
Straight line, which is how many degrees?
180.
180. Okay. KN bisects JKL, right here. So what do I know about this angle and this angle?
Congruent.
They are congruent. Okay. Now they're going to give you some things to plug in. LKM, this small angle here, is x plus 2. So let's write that in. X plus 2. And then the measure of LKN is 8x minus 3. 13, sorry. So if LKN is 8x minus 13, what do I know about JKN? Same thing, 8x minus 13. Okay? We want to find x and the measure of each angle. Okay? So, who can tell me first, how could I solve for x here? Set what equal to 180? Good. All three of them, right? So what am I going to do with all three angles? What operation? Add them all together. 8x minus 13 plus 8x minus 13 plus x plus 2 equal to 180. Good. So even if we have three angles that form a straight line, we know they have to add to 180. Let's add like terms first. What's 8 plus 8? plus 1. So we get 17x. Negative 13 plus negative 13. Negative 26 plus 2. Negative 24. Okay, we add 24 to both sides. We get 17x is equal to 204. Last step always. Almost always. I shouldn't say always. Okay, we get x is equal to 12. Okay. Now is the easy part. We just go plug 12 back in. So JKN, or JKN is our first angle over here on the left. So I'm going to do 8 times what? Minus 13. Okay. Anybody got that yet?
You got 7?
83.
8 times 12 minus 13?
Oh, 83.
83? 83 sounds right.
And then
Okay, and then in KL, right next to it, has to also be what? 83, because we know those two are congruent, okay? So, also 8 times 12 minus 13. Okay, what about LKM? 12 plus 2, right? So we know that's 14. Now, those three angles we know add to equal what?
180.
We know those three together equal 180. What's the last angle it asks us for? NKM, right? These two. So what do I have to add together? Yes, 83 plus 14. Okay. So, again, kind of like I tell you guys often, the majority of the stuff we're doing is either setting two things equal to each other or adding them equal to 90, add equal to 180, any of those types of things, or just add them together equal to a total angle, okay? But we're doing a lot of solving equations and then just plugging back in. Yes?